So, of course, I'd like to start by saying thank you, everyone, for joining. My name is Cody Armstrong, and as you can see from the slide today, we're talking about 10 Onshape tips that I would recommend for the new user that's coming from SolidWorks. So, 10 Onshape tips for SolidWorks users. As I always say with these webinars, I really encourage you to ask any questions that you'd like. There's a questions dialog in the GoToWebinar control panel. Feel free to ask any question, and I'll do my best to stop and address them as we're going through today's webinar. And it's going to be a short webinar. I really just wanted to focus on, some of the more commonly asked questions I get from SolidWorks users and some tips that I give when they ask those questions. So if you've come from SolidWorks and you're learning Onshape and you're trying to understand, a few of the differences that exist, today's your webinar. So again, feel free to ask any questions, and I'll do my best to stop and address them from time to time. As I mentioned, today's really short webinar. We're going to focus strictly on 10 tips for Onshape users that came from SolidWorks. So I'm going to walk you through each tip. I like to do this like in an old school radio countdown kind of format where we start at number 10 and work our way down to do number 1. And I've tried to pair this again based on the number of questions I get and the content of those questions. Now, before I begin, there is one thing that I always like to ask of the audience. And if you're a SolidWorks user, chances are, you're interested in Onshape using it for professional use. But I always like to ask the question, if you're using Onshape, is your interest in Onshape for professional use, or using it for a hobby, or, maybe for your 3D printer project, or are you out there using it for a professional project? And I'll give you just a moment, and we'll close this out and move on. And it looks like nearly 3/4 of the audience is using Onshape for a professional application, which is awesome. And it's definitely going to tie into a lot of what we're talking about here today. When you're coming from a SolidWorks environment, of course, the big thing that you want is I want to be able to easily pick up Onshape and get moving. And so that's the goal of today. Now, as I mentioned before, feel free to ask any questions you'd like. There's a questions dialog in the GoToWebinar control panel. I see the questions pop up live, and I'll do my best to answer them as we're going through the webinar. So let's dig in. And I'm going to start, as I mentioned, with tip number 10, and that is import pack and go zip files. This is one that we get questions often. How do I bring over my Onshape assemblies, my SolidWorks assemblies into Onshape? How can I bring them all in? I don't want to import part for part, all of my parts that I've created in SolidWorks. How do I bring in an entire assembly? And the answer to that is using a pack and go zip file. So if you're not familiar with it, in SolidWorks, under the file menu is a command called pack and go. Pack and go will take all the parts in your assembly, all the sub-assemblies, and will put them in a single place. And in that pack and go command is an option to save to zip file. And essentially what that gives you is one zip file with the assemblies, the parts, everything together in a single place. Then you can take that zip file and import it into an Onshape document. We will then translate it and build out all the subassembly tabs and part tabs that exist in that zip file. So it's one of the biggest tips that I can give you. I always like to start with it because it's one of the more common questions a new user will have if you're coming from SolidWorks. Use the pack and go zip file function to import your assemblies. Now, as I mentioned before, if you're not familiar with it, pack and go is under the file menu in SolidWorks, and it has an option to save to zip file. Now, a brief demo of how this is handled on the Onshape side of things. Once you have a zip file, it's very simple. You click import on the documents page, and you browse to the file, the zip file from SolidWorks. So here's a comealong.zip that I've brought in from SolidWorks, and I'm importing it into Onshape. Now, one important thing that I want to mention is make sure that the zip file name matches the top level assembly name in SolidWorks. And that's a default setting, so if you don't change the file's name, you should be fine. But just keep in mind, don't change the zip file's name before you import it. It must match the top level assembly in SolidWorks. So from there, I just choose open. Right, I get my import options, just as if I were importing any other file. I hit OK, and it imports. Right, so that's really all there is to importing a SolidWorks assembly. The key thing is making sure that you have that zip file that you can then import. Once you import the zip file, it will of course upload and then translate so that you can actually view the Onshape data, or excuse me, the SOLIDWORKS data inside of Onshape. Right? So if we left click the come along here, it will take a moment to translate it, but what you'll get is all the tabs for subassemblies. You'll get a tab, of course, for your top level assembly. So here's my SOLIDWORKS designed come along imported into Onshape. So again, you get tabs for top level assembly, you get tabs for subassemblies. The parts will come in all together in a single tab, and they will come in the orientation they were modeled. So that's one important caveat that I want to point out. And then also another question that gets often asked is, does the sketches or the features carry over? You know, if I create a sketch in SOLIDWORKS, create a part, and then I import that into Onshape, do I see the sketch in the feature list? And the answer is no. It does not translate feature for feature. So you do get all the parts, you get the subassembly architecture, the hierarchy that you're used to, but you don't see the individual features and mates that make up that assembly. And the key reason there is there's just a lot of differences between CAD applications that make that really not practical. So that's one of the first things that I wanted to mention. Pack and go importing a zip file. You can bring in, potentially hundreds of thousands of parts at once by using a single pack and go zip file. It's one of the easiest ways to bring over an entire project from SOLIDWORKS. So that is tip number 10. Moving on, tip number 9 in my list is configurations. And it's one of the more common questions that we get from SOLIDWORKS users. I use a lot of configurations. What would I do in Onshape? In Onshape, we have the concept of what we call branches, and branches allow you to explore design variations. And it's probably the best tip that I would give if you're trying to create a lot of design variations in Onshape is create branches. Branches are created off an established version, and you can create as many branches as you'd like. And you can even take two branches and merge them together at some point in the future. So if you decide that you like the ideas of two different configurations or branches, you can take them and merge them together. Now I have a short demo of this, so I'm going to show you just creating a branch and then going through that process. So here's a simple arbor press that I've designed. And let's say that I want to explore, a version with a different base, or I want to build a configuration, quote unquote, of this arbor press that's different. And I don't want to impact this original design. The first step, and very important, is creating a version. So you'll see the button here, create version. Once you have an established version, here you'll see initial version, I can select the gear and say branch to create a workspace. And this is going to create a separate branch. Let's call this the square base. Right, click create. Now anything I do in this branch does not impact main, which is where I was at just a moment ago. And as I mentioned, you can do all the design changes that you want here. And again, it does not change anything downstream. Right? So if I decide to edit this and start adding some faces, for instance, editing features only applies to the branch that you're in. Okay? So an important thing to point out, just make sure any design changes that you want happen in the right branch. Right? So now I can go through, select these individual contours, add to this feature, and create a square base version. Right? So we're editing this extrude, got all of our profiles. I'll hit the green check. That will then go through and rebuild and build a square-based variation of my arbor press. The key thing here is, of course, anything that I'm doing only applies to square base. If I go back to main, you can see the design is the original, right? It's not impacting that. So you have these independent spaces to work, so to speak. So think of branching as your equivalent to configurations. It gives you that ability to explore different design variations. All right, so moving on, the next tip that I have, tip number 8, the cut is not a separate button in the interface. And that's one important thing that I think a lot of SOLIDWORKS users miss on first glance is, I don't see an option to cut. Where's the cut button? And it's important to keep in mind, extrude, revolve, sweep, and loft all have an option within them to remove, and that's your cut. And the idea is really trying to simplify the interface. So you go to the same button, whether you're creating a new feature and adding geometry, whether you're creating a cut, whether you're creating a whole separate part, it's all the same command. So let me show you a quick example of this, not terribly complicated, but I do want to point it out. When you're working in, really any part studio, trying to create any feature, let's say that I'm designing this shock and I want to cut a hole in the bottom of the shock. And I've created my sketch 3 here. Notice again, no separate button for cut. I click extrude, then choose remove. That's the key. And then select the sketch that I want to remove. Now, in my case, I actually have several different parts. So I'm going to say I want to merge this cut with the shock here, and I want a symmetric cut. And that's another small tip that I have for the SOLIDWORKS user. If you're familiar with the option of mid-plane in SOLIDWORKS, we have what we refer to as symmetric, which gives you very similar behavior. Okay? So symmetric, I can hit the green check, and now I've created a cut in the end of this shock. And again, the key is whether it's extrude, revolve, sweep, loft, they all have that option for remove, and that will create your cut. So that's a big tip. It's one that can trip a lot of new SOLIDWORKS users up. Just keep in mind we don't have a separate button for cut. It's built into extrude, revolve, sweep, and loft. Now, let's move on to the next tip, and that is top-down design. And this is something that we get asked quite often. How do I build parts in context at the assembly level? And it's just because that's a common practice in SOLIDWORKS. I insert parts and I build parts with contextual relationships at the assembly level. In Onshape, we've taken a different approach to this. You do not create new parts or modify existing parts in the assembly. You won't see those features listed in the assembly. They're only done at the Part Studio level. Now, what's different is in Onshape, you can have multiple parts in a single Part Studio, and it's actually a far faster way to do top-down design than building with the assembly context and having motion and all those things to worry about. So just keep in mind, if you're trying to build a top-down, if you're familiar with the concept, top-down just means building multiple parts together with relationships to each other. We do that in Onshape in the Part Studio, not in the assembly. Okay? So a short demonstration of this, I wanted to point out real quickly here, the cantilever clamp. So this is a single Part Studio in Onshape. And in Onshape, one Part Studio can have a single part. I can have any one of these parts by themselves, or you can model multiple parts together. And you can see in this Part Studio, I actually have 10 different parts. Large arm, short arm, threaded hinge, all these parts listed here. So this is a multi-part Part Studio, and the reason to do this is the same reason to do anything in a top-down manner. It just allows me a single place to change the design and have it impact many different pieces. I'm not taking a lot of measurements between parts. I can drive everything off of previous geometry. Now, as I mentioned, this is a multi-part Part Studio, so you can build all the parts together in a single place. But you'll notice that I didn't model anything that wasn't unique. In other words, this is a clamp arm that has 2 sets of arms. There's going to be another set on this side. And I could easily mirror them, but essentially this is the same part. So when we talk about assemblies, assembling all the instances, testing out the motion, that's when we get into assemblies. And that's really what assemblies are for. So in Onshape, you create an assembly so that I can test dynamically the motion out of my assembly. And I can also insert all the various instances of my parts, my nuts and bolts, and all the multiples of parts, put them all together and get an accurate bill of materials and so on. Okay. So again, driving back to the top-down design concept, you can model multiple parts together in the same Part Studio. And this is the equivalent of building in context in the assembly in SOLIDWORKS. Real quick question. Are all parts in a Part Studio, I make a long feature list when a part becomes a little more complex, how to work around it? Keep in mind, one of the biggest tips that I have for users with long feature lists is doing filters and searches. So if you go through and name your features, you can create filters and searches to kind of organize and easily find pieces within your feature list. And you could query by things like name. You can see a little tooltip there, type, feature, and so on. So you have parts. I can say, show me all parts with this name, or this in the name. So anyway, the feature list is an easy way to break down the feature list filter, I should say, is an easy way to break down the feature list when you start to have lots and lots of features. All right, so moving on, as I mentioned before, this is a single part studio with multiple parts modeled in this single space. How would you go about doing that? And what I'd like to do is give you a simple example. So let's break it down a little bit here. In fact, let's start from scratch. Let's delete everything but the sketch that drives it. And as I mentioned before, one of the biggest advantages of doing something like this is having a single feature driving multiple things. And this is a great example. I have one sketch called main sketch, and actually going to drive several parts off of it. So I'll select the extrude command, and if you just click the sketch in the feature list, you'll grab everything in it, right? Which isn't exactly what I'm looking for. This one sketch is going to drive many different things. So I'm going to X out of that. I'm not going to choose the entire sketch, and rather I'm going to select the profiles, the individual pieces of the sketch that I want to extrude. So we can select all our pieces here and create the exact shape of the arm that we need. Right? So now I'm only using part of this sketch to drive this feature. Right? Green check. Now I have the first arm in my clamp. Now we can do that again. I can use the same sketch to drive the second arm as well. So again, I click extrude, and this time I'll select the other profiles that I'd like to extrude, the other arm, right? So now I'm just selecting different pieces of the same sketch, but now it's really easy for me to say, okay, this is not merged with the original part. Instead, it's a new part. And that's really the key thing. So as I'm creating this new extrude, I actually want this to be a separate arm, not added to this arm. So I click new. Right, I click new, that will create part 2 in my part studio. And so now I've modeled 2 parts that are both driven off of the same sketch. Right, so if I edit sketch 1, both parts will update. And you can go on for, a long list of features that are all driven from this single one, and allows you to make a change very quickly and have it propagate to potentially to hundreds of parts. With just a few clicks. And that's the idea behind top-down design in general. If you've come from a SolidWorks modeling environment where you did that, just realize a multi-part part studio gives you very similar behavior. In fact, oftentimes it's a much faster approach in Onshape. So let's get into the next tip that I have for you, and that is tip number 6. And this is just a general tip with regards to mates. It's one of the more common mistakes that a new SolidWorks user, a new Onshape user coming from SolidWorks will make, and that is they will try and mate parts in the assembly using the same techniques they used in SolidWorks. And you can get away with that. There is, the equivalence in Onshape, but there's a much faster approach if you really learn the technique that we've tried to teach, and that is using mate connectors. So a brief description of this. In Onshape, we're not using combinations of faces to mate a part. So if you're familiar, for instance, mating a bolt to a hole. If I were to mate a bolt to a hole in SolidWorks, oftentimes I would use a combination of mates. I would use, circular face to circular hole, concentric, and then maybe some kind of coincident or planar between the flat faces of the bolt and the flat faces of the part. It's a combination of things to get it into position and not spinning. Often even 3 different mates. In Onshape, that's one fasten mate. And the difference is, instead of using a combination of faces to locate, we use what we refer to as mate connectors. And you can think of them as just a connection point. Where does the part connect to this part? What's that point? And we establish a point and then create a relationship between them. The type of mate that you choose defines how much motion there is. Right? So for instance, a fastened mate, when I put a bolt in a hole, I don't want it to move in any direction. That's a fastened mate. Right? Whereas if it's a spinning shaft, for example, that would be a revolute mate. Revolute allows for rotation. So the key thing there again is think of it as a little bit different philosophy. Rather than selecting a combination of things to locate a single part, use its connection point to define how it connects to another part. Again, we refer to them as mate connectors. So let's do a simple demonstration of this. Bear with me for a second. I've got two part studios, and as I mentioned, you can model a part by itself. Here you can see I just have one part in this part studio, my sketches and features here, but only one arm, and that's fine if you like that approach of modeling one part at a time. There's nothing wrong with it, but you can also model multiple parts together. So here I've got three different parts. This is a little pneumatic clamp, and I have a cylinder, I have an O-ring, and I have a plunger. So I have three parts modeled together in this part studio. Now I want to take them and assemble them so that I can test the motion out. Remember, in a part studio, we can't dynamically drag the plunger up and down, but in an assembly, we can. So I'll jump to an assembly, I'll click Insert, and I'll select the entire hydraulic components part studio. Because they're all modeled together, they all come in together in the same orientation. So it's really easy to insert all three, but they're not constrained in any way. So just keep in mind, when you initially insert your parts, they're not fixed. You need to define what is your fixed part. So in this case, it's the cylinder. I'll right-click, say Fix, and now the cylinder's fixed, but these other two parts are not. Now, another big tip that I have is oftentimes in Onshape, you don't even have to mate parts at all. In this case, the O-ring was modeled in the right position in the part studio. I've inserted it into the assembly. It comes in the same position, and it doesn't move. So it's already in the right position. I just need to group it with other parts that don't move. So essentially, I can select any parts in here and say group, and they become a fixed thing. They work together as one. And it's an easy way to constrain parts when you've modeled them together like I've done here. I can select group, select the cylinder and the O-ring, and now I don't have to mate the O-ring in place. Right? It's grouped with the cylinder's fixed, so it's fixed in its current location. Okay. Now, another tip, you can copy and paste parts. I can use Control-C, Control-V. So just a tip, if you like keyboard shortcuts, Control-C, Control-V, or Command-C, Command-V if you're using a Mac. But now we get into the big advantages of Onshape mates, and that is, I want to mate the O-ring to the groove, right? I have a second O-ring, I need to put it into the bottom groove, and in a more traditional CAD system, this would be a combination of things. Some kind of concentricity, some kind of planar alignment between faces, something like that to keep the O-ring in position and not spinning. In Onshape, this would be considered one fasten mate. So I select fasten, then I select, as I mouse over that mate or over the part, you'll see that mate connector appear. And it looks like a little coordinate system at the center of this O-ring. And again, think of it as your connection point. So I want this point on the O-ring to connect, obviously, to the center of this groove. So as I move my mouse over the center of that, over the groove, you'll see the mate connector appear for it, right? If another tip, if you hold down Shift, it will lock those mate connectors on the screen. So here you can see I'm moving the mate connectors around. I'll choose the center one, right? And now I've mated the O-ring to the cylinder. One mate put it into its position. Okay. Question, how did the mate connector get in the O-ring model? It's a very good question. It's automatic. So as you select a mate, if I choose any mate, let's grab this plunger. And let's say I want a cylindrical mate, and I just move my mouse over the part, they automatically appear. And what you'll see is common points that you may want to attach to. I want to attach to the end of the shaft or the middle of the shaft. Those will be connection points by default. Now, you can also create your own connection point. So if you have one of those scenarios where Onshape doesn't pick the right point that you want to attach to, you can just create a mate connector manually. So just a tip, you don't have to use these auto-selected points, but oftentimes, I'd say 9 times out of 10, they're useful. They're what you want, and you don't need to go in and create anything manually. So again, just moving my cursor over it while in a mate command, I see these points appear. In this case, I want to mate the center of this shaft into the actual cylinder. So as I move my cursor over the hole in the cylinder, I see the top, midpoint, and bottom, and I can keep going down if I wanted to. In this case, we'll just choose the bottom of this hole, and it brings those 2 points together. So again, all we're doing is choosing the connection point, and it brings the 2 connection points together of the 2 parts. Now, the question then comes up, well, how do I know that this is going to move the way I'd expect? This is supposed to spin up and, it's supposed to move up and down, and it's supposed to be free to spin. How do I know that that's working? And one big tip that I have is while in the mate command, you can hit play, and it will animate the degrees of freedom that you have, the motion that you have, right? So if you want to see, how is this free to move, just click play. And you can also try out different mates. So I can say, okay, well, let's see what a slider mate looks like. Click slider, hit play, and now I can see, okay, it's free to move up and down, but it can't spin, right? Let's see what a ball mate looks like. Click ball, hit play. That is definitely not the mate that I'm looking for, right? Rotation, but no linear travel. So we have all these different mates. A big tip that I have is you can try out different mates and see the one that works with you just using that, play or animate command. In this case, we want cylindrical. Cylindrical allows it to rotate, and it allows it to move up and down. So I hit the green check, and now I've created that mate. And by the way, I didn't mention this, but all the mates, the group command, will show up in your instance list here on the left. So if you need to edit or change something, you can right-click the mate in that list. So that's a big one. Again, the mate connectors are a little bit different approach to attaching parts, but oftentimes it means fewer mates in your list of mates, just because instead of using a combination of faces, you use a single connection point between those parts. Do we create, this is a question by the way, do we create mate connectors in the part or at the assembly? And you can do it either way. What I'd recommend is if you use that part in several assemblies, you would want to create the mate connector at the part level, because then it would go wherever you insert the part. If it's a one-off thing and you just need a mate connector for this one assembly and you don't need to see it at the part level, then you can just create a mate connector at the assembly. So it's entirely up to you. I think there are applications for creating it at the part or the assembly. It really depends on what you're doing. Okay, so we've discussed mate connectors. As I mentioned before, we're taking a point from one part and a point from another part and bringing those 2 points together, and then define the movement between them based on the type of mate that you choose. And of course, in an assembly, the key thing is you can dynamically test the motion out. So I can grab and drag and see that this plunger is free to slide up and down. So real quickly, one more time, I want to insert this swing arm, the clamp arm, and I want to show you a quick example of what will happen if you have an already determined mate connector. And as I mentioned before, most of the time you won't need this. You just mouse over the geometry and the mate connectors that appear will be useful. But you can create your own. So you can see in this finished swing arm, I have an already created mate connector. And it just makes it easy for me to define that point real quickly. So just trying to drive home again, I guess I inserted 2 of those arms. Just trying to drive home again the idea that you're using a mate connector on each part. And you can create your own beforehand, or you can just use the Onshape provided ones you get when you mouse over geometry. All right, so that is the tip on mates, and it's, again, a big one. It's a bit different than SolidWorks, but oftentimes means that you can have far fewer mates, far quicker assemblies to build. So let's move on to the next one. This is another frequently asked question. What about measure? How do I measure in Onshape? Is it a button? Where do I find the measure button? And the answer is it's built into Onshape itself. So if you select any geometry, you'll find a measurement in the bottom right corner. And it's not a command that you have to turn on or off. It's always there. So anytime you select anything in Onshape, look in the bottom right corner if you're looking for a value, a measurement. So a quick demo of this. Real simple to show. If I wanted, for instance, a measurement between, what this radius is. What if I want to know what that radius is? I left click the radius, and again, in the bottom right corner, there's the measurement, right? So 1.75 inch is the radius. I can select 2 points, and it's going to give me the distance between those 2 points, minimum distance in the bottom right corner. So really the key thing is just select whatever it is that you want to measure and look in the bottom right corner. Now you can do things a little bit more complicated, like I can do minimum and maximum values. I can do deltas between two things. So it will give you more information if you expand out a bit. So here you can see I have minimum distance, center distance, and the delta values for it. So just keep in mind, all the measurements are there. Just click the geometry. If I click a face, for instance, here's the area or square inches that face has. So just keep in mind, let's select a circle, for example, diameter 0.25. Okay. Another question that ties in with this then is, what about weight? What if I apply a material to a part? How do I figure out how much it weighs? The first step, of course, is to assign a material. So if you right-click a part and you assign a material, let's choose aluminum, let's say 6061. Okay, green check. So now that you've applied a material, if you left-click the part, you'll see in the bottom right corner, same place as the measurement, a mass properties. And then you can see mass, center of mass, and all those properties that you may want. Important step, though, make sure that you've assigned a material before you try and do this. Okay? But again, just left-click the part. You'll see the little mass properties icon where the measurement normally is, and you can click on it and get the mass. Okay. So it kind of ties in with the measure, but just keep in mind, measure is just one of those things that's always on and Onshape. Just left-click whatever it is that you want to measure, and you should see that measurement appear in the bottom right corner. So moving on to the next tip, revisions. This is another commonly asked question. Real quickly, before I get into it, a question. Branch basically makes a full copy of the workspace, so I can import, etc., and does not affect the main workspace, and that's true. So the question, if you create a branch, it creates basically a copy of the full workspace. So if you import, etc., if you make any changes in that branch, it does not impact the main workspace or any other workspace that you may have. And so, yes, the answer is yes to that question. It is one of the big benefits. If you create a branch, you don't have to worry about impacting others. Okay, so the question that often gets asked from a lot of SOLIDWORKS users is, what about creating a revision? I have EPDM or I have XYPDM system, and we manage revisions inside of it. How would I go about doing that in Onshape? How would I go about accomplishing, being able to see and capture those milestones in the design? And the tip is, in Onshape, we create a version. In Onshape, a version is a view-only snapshot of the entire document. And the key thing there is you can always go back and look at it. So let's say I'm making a product, and I'm pushing the product revision A out to market. And 6 months from now, we get an ECO, and we need to create revision B. And we create revision B, and we realize, 6 months later, we need to go back and look at revision A, maybe export the models of revision A. That's the idea behind versions. You create a version, it allows you to go back and look at those models at that state very easily. Now, this is different entirely from history, which we're going to get into in just a second. But again, think of creating a version as you're capturing a snapshot of everything in the document. All parts, assemblies, drawings, even things that you've imported. So pack and go zip files or text files or spreadsheets or any miscellaneous project file, you can import and version control using create version. Again, main thing is really just capturing milestones. You've reached a point where, it's Rev A and we're ready to go to market, but I may need to go back to this point at some time. That's a perfect example where you need to create a version. Now, it's not very complicated to show, so I can jump into a document here. You'll see an icon in the top left for create version, and you give it a name. Let's say revision B. Okay. You can add a description if you'd like. You can edit specific properties within the version, and this is an important one if you're doing creating a bill of materials and then maybe exporting that to PLM systems and so on. You can go in and enter descriptions, part numbers, revisions, states for individual parts within the document and have that captured as part of creating the version. So just keep in mind, you can edit the properties associated with it, but that's really it. You click create version, you click done, and it creates a version in your versions manager. So right next to the create version is a little icon for versions, and you can see I have Rev A, Revision B, and I can left click on them and see the design as it existed at that time. So if I click on Rev A, it's going to load the model as it existed on 11:44 a.m., August 25th, 2015. So I'm rolling back to that state. If I left click Revision B, it's going to take me to a view-only version of the design, of the version I created just a second ago. So just keep in mind, it's grabbing a snapshot that you can always go back and look at or export the models as. That's another commonly asked question. So that is versions. Versions are view only. They cannot be edited. So an important tip, once you create a version, that's it. It cannot be changed. All right, so that is creating a version. Again, the commonly asked question there, what about creating revisions? I use, a PDM system to manage revisions. In Onshape, we can create versions to capture those milestones in the design. Now, the next one, keyboard shortcuts. And I find that a lot of SOLIDWORKS users love keyboard shortcuts. And in Onshape, we have a long list of keyboard shortcuts, and they can make a huge difference in how quickly you really start to come up and use Onshape. And the big thing is, a lot of Onshape commands you can find in right-click menus, you can find in the toolbars or interface, but keyboard shortcuts still seem to be one of the more common approaches for the 8-hour-a-day hardcore engineers. So we do have a long list of keyboard shortcuts. You'll find them under the help menu. And if you're not familiar with it, the help menu is the little question mark menu in the top right. If you click that question mark, you'll find a lot of useful links. One of them is the keyboard shortcuts. All right, so if I jump into a document here, the help menu is in the top right. Again, the question mark menu. If you click it, you'll see the option for keyboard shortcuts. Okay. So I click keyboard shortcuts, and it launches with all of our keyboard shortcuts. Now, a commonly asked question, can it be customized? The answer is no, not yet. That is something we're working on, but right now this list can't be changed. But you have just about every command that you can imagine. So different areas. You have keyboard shortcuts for sketches, keyboard shortcuts for Part Studio or assemblies or drawings. Another tip that I have is there's a little arrow here. You can pop this out into a separate instance of your browser, essentially, and move it to a separate monitor or print it. Another commonly asked question, I can right click and print this. So just a tip, you can pop out the keyboard shortcuts and put them on a separate monitor or print them. All right, so that's the keyboard shortcuts. You'll find it again under the help menu. Question, I would like to generate an animation video to show to others. I have not been able to find that capability in Onshape. We do have the ability to animate a mate, but we don't have the ability to capture a video and create a video file for you. So what I've seen other users do in that application is just download a video recording software. There's lots of free ones out there, and there's some with free trials, and then just record their screen while animating in Onshape. And just a tip, you can right-click any mate in Onshape, that has motion, and you'll see an option to animate, and then just do a screen record and send that out. But Onshape itself doesn't have a way to convert the animation to a video file for you. Again, that's something that you have to do with a separate application. Okay, so moving on, the next tip in my list, and it's a big one, but it's a real simple one. I think if you've been using Onshape a while, you may say, no, duh. But I think for the new user, this is an easy one to miss. And it's still one of the most common questions we get. Where's the save icon? How do I save? And it's a hard practice to break coming from a file-based system where saving is everything, right? Saving can mean not losing hours and hours of work. It's something you simply won't have to do in Onshape. So, you don't have to impulsively hit Control S or, find the save icon or any other shortcuts you may have to remember to save, auto save, or any of those things. In Onshape, everything that you do is saved forever. It's not dependent on the session or this file or anything. Everything is stored within that document. So the key thing is, I think for new users, there is no save icon, so you don't have to look for it, and you never have to worry about saving. So you don't need Control S. You don't need to find the save. So the big thing is, in Onshape we have what we call history, and a history is essentially every change to a document going back to the moment the document was created. So it's essentially an audit trail of everything that's ever happened to the document in a list. And the list has who made the change, when they made that change, and what change was made. So you'll see in this person inserted this feature at this time. And the neat thing about this is you can go back to any point in that history and restore to it. So again, there's no save. Everything you do is saved. If you don't like a change that was made, just go back to before that change was made in the history and restore. And it's not limited. In a SolidWorks application, you have maybe 8, 10, 15 undo steps that you can do before you're out of luck. In Onshape, you have an infinite. You can think of history as an infinite undo. So how do you access the history? Real simple. If you go into any document under the same versions toolbar that I was showing you a second ago, if you go into, for instance, show changes, you'll see every step that's happened to the document going all the way back to the moment it was created. So I can see that I changed on August 20th, 2015 at 10:47 a.m. I inserted a tab called Finished Swing Arm. So I can see every little change, whether it's a feature change, a sketch change, a changing the appearance, inserting tabs, removing tabs, any of that shows up in the history. And the most important thing I always like to mention is you can decide, okay, I want to go back to this point. I don't care for the changes. Let's restore the document to this moment in the history, right? So again, just trying to drive home the idea, every change, everything you do in Onshape, in a document, is stored in the history, and you're going to see it in a list. You can go to any point in that history and restore, right? So you never have to worry about, did I break the design? Am I going to get to a point where I can't go back and I'm going to leave it in a broken state? And we run into a lot of users that are simply afraid to change the big top level model, because what if they can't fix it if they break it? And then they don't want to leave this big important model in a broken state, so they just simply don't touch it. In Onshape, you never have to worry about breaking it, so to speak, because even if you go ahead 3 days and changes and realize, oh no, I need to go back to where we were 3 days ago, you can do that, and you don't have to think ahead or capture revisions or any of that. It's automatically done for you. So again, history, you can think of it as an infinite undo, but essentially it's just a big list of all the changes you've made. And as I mentioned before, because of Onshape's nature, because you can share a document with multiple people at the same time, this also becomes a list, an audit trail of all the changes. So if 2 or 3 people are working on this part, I can see who did what and when. And it's a list, right? So that is history. The big tip is you don't have to worry about saving. Never have to save in Onshape. That's done automatically. Okay? So think of it as an infinite undo. All right, so a few questions that I've seen popped up. Do you lose the history after you've made a revision? The answer is no. No, you do not. You do not lose the history after creating a version. Now, if you create a copy, you will lose the history, and that's an important thing to point out. So just keep in mind, if you create a copy, you will lose the history, but just simply creating a version in a document or creating a branch in a document does not eliminate the history. Question, is there a way to animate multiple mate connections at the same time in the assembly? No. That's a good question. Right now, you're animating one mate at a time. Okay, so last tip number 1, and it's definitely the most important tip that I would recommend for the SOLIDWORKS user that's trying out Onshape for the first time. And it's one of the biggest things, especially if you find yourself having to go back and forth between CAD systems. And that is rotate, pan, and zoom. In Onshape, by default, our rotate, pan, and zoom is different than SolidWorks, and that's oftentimes one of the easiest things to miss, to get hung up on when you're getting started. All of a sudden, the zoom is backwards, and rotate is this, and I'm used to this. You can change the rotate, pan, and zoom settings in Onshape to match SolidWorks specifically. And this can be a huge usability improvement if you're coming from SolidWorks or if you've got to go back and forth between SolidWorks and Onshape. So let me show you this. It's probably the biggest tip that I have for the SolidWorks users out there. Under Manage Account, so in the top right corner, you have your username. If you select it, you've got Manage Account. This is where you'll find all of your account settings, units, email address, security options, all that kind of miscellaneous administrative stuff associated with your account, you'll find under Manage Account. Under Preferences, here on the left, if I scroll down, you'll see View Manipulation. The reason this is so big is I can set this specifically to SolidWorks, and it will change the middle wheel drag or middle wheel rotate, and the zoom settings will be reversed. All the things that you're used to in SolidWorks will carry over into Onshape. So again, big tip that I'd recommend, and it's not just specific to SolidWorks. If you've come from NX or Creo, or you just like the mouse settings that they use, you can set your Onshape settings to match that. Okay, but a big tip, we have SolidWorks as a specific view manipulation option meant to ease that transition from SolidWorks to Onshape. And it just means that you don't have to relearn zoom or rotate or pan. Okay. One last thing I want to mention is when you change these, make sure to click the big save button just to capture that so that it refreshes. All right. So click save and you'll be done. But again, tip number one, change your view manipulation settings to what you're used to in SolidWorks. It'll make it a much easier transition when going from SolidWorks to Onshape. So that is what I had planned. A quick question. Can I make a single part transparent in the assembly? You can make a single part transparent, but it must be done in the Part Studio, and that will be reflected in the assembly. All right. So just keep in mind you can change the transparency associated with the part, but you must do it to the Part Studio and then have it update in the assembly. Another tip, and this is just kind of an aside, in an assembly, or Part Studio for that matter, you can also right-click and isolate. So I can select a whole series of parts or just a single part and isolate it, and it will make all the other parts transparent. Right? So that is, it is changing the transparency state of different parts at the assembly level without having to change the actual appearance. But otherwise, you would need to go into the Part Studio, right-click a part, and edit the appearance and change your transparency. Okay? And anything done here will, of course, impact the assembly. All right, so that is what I had planned. Now, before I let you go, I have one last question for the audience. I'm going to stick around and answer any questions that you have. So feel free to ask any questions in the questions dialog of your GoToWebinar control panel. But if you would bear with me for one more question, real quickly, are you interested in a private demo or discussion with one of our account managers? We can get into more specifics on your application and how Onshape might fit into what you're currently doing. So if you're interested in meeting with one of our account managers, discussing more specifically how Onshape might apply to what you're doing, definitely let us know. Select yes, and we'll have one of our account managers reach out to you. So that is what I had planned. I'm going to stick around for any questions that you have, so feel free to ask any questions in that questions dialogue. But that's it, everyone. Thank you, and have a good day.